Imagine a place where the universe simply ends. A point where the laws of physics, the flow of time, and the very concept of reality are crushed into a single, impossible point. Imagine a trap door in the fabric of space that lets light in but never lets it out. These are not just objects of science fiction, they are the most terrifying and magnificent residents of our cosmos. They are the black holes. From microscopic sparks that vanished in a heartbeat to titans that hold entire galaxies in their grip, we are about to journey through the 5 levels of the abyss. Hello everyone, and welcome back to the channel. Before we dive into the darkness of the deep cosmos, if you enjoy exploring the mysteries of our universe, please take a quick second to hit that subscribe button and join our community of space explorers. Now, let's begin our descent into the unknown. To understand the hierarchy, we must first understand the beast itself. At its simplest, a black hole is a region of space where gravity has become so overwhelming that nothing, not even light, the fastest thing in existence, can escape. It is a cosmic no man's land. Picture the mass of our entire sun being squeezed down until it is only a few kilometers wide. This extreme compression creates a curve in space-time so steep that it forms an event horizon. This is the point of no return. Once anything crosses that boundary, be it a grain of dust, a beam of light, or a massive planet, it is lost to our universe forever. They are the inevitable conclusion of physics pushed to the absolute edge. Level 1. The stellar black holes. These are the ghosts of dead giants. Not every star is destined for this dark fate. Our own sun, for instance, is far too small. It will die quietly as a white dwarf. But for the true heavyweights of the galaxy, stars at least 20 times the mass of the sun, death is a violent, spectacular affair. When their nuclear fuel runs out, the core collapses under its own weight in a fraction of a second, triggering a supernova explosion that can outshine 1 billion stars. What is left behind is a stellar black hole. Think about the density here. We're talking about an object with the mass of 10 or 20 suns, yet it is no larger than a city like London or New York. If you were to replace the core of the Earth with a stellar black hole, our entire planet would be swallowed in the blink of an eye. Because they give off no light, we find them by the chaos they cause. We see them when they tear gas away from a neighbor star, creating a swirling, glowing disk of X-rays that screams across the vacuum of space. The most famous example, Cygnus X1, was discovered this way. It was the first black hole ever confirmed, proving that gravity is indeed the ultimate master of the universe. Level 2. The intermediate black holes. If stellar black holes are the seeds and supermassive ones are the forests, then where are the trees? For years, astronomers faced a frustrating silence in the middle ground. Logic dictates that there must be middleweight black holes, objects weighing between 100 and 100,000 suns. These are the missing links of cosmic evolution. They are the key to understanding how the universe built its largest structures. Finding these intermediate giants is like chasing shadows in a dark room. They are quiet. They don't always feed on stars, and they don't sit in the centers of galaxies where they are easy to spot. Instead, we find them hiding in dense star clusters or small dwarf galaxies like HLX-1. Imagine the entire weight of a star cluster compressed into something the size of our moon. That is the intermediate black hole. They are the silent giants of the cosmos, the quiet architects that may have helped the first galaxies grow, yet they remain one of the most tantalizing mysteries in modern astrophysics. Level 3. The supermassive black holes. Now we reach the true kings of the dark. These are not merely remnants of stars, they are the anchors of reality. Every large galaxy we have ever observed, including our own Milky Way, hides a monster at its heart. At the center of our galaxy lies Sagittarius A star, a black hole 4 million times heavier than our Sun. But even that is a dwarf compared to the Titan in the galaxy M87, which weighs over 6 billion suns. In 2019, humanity saw the face of the abyss for the first time. The Event Horizon Telescope captured the image of M87's black hole, a glowing ring of fire surrounding a shadow of nothingness. These objects are larger than our entire solar system. They are so powerful that they act as galactic engines. As they consume matter, they shoot out jets of energy that can travel across thousands of light years, regulating the birth of new stars and shaping the very evolution of the galaxies they inhabit. They are both the destroyers and the creators of the cosmic order. Level 4. The primordial black holes. To find these, we must travel back in time, past the birth of the stars, to the very first second of the Big Bang. These are not born from the death of matter, but from the raw chaos of creation. In the cooling soup of the early universe, tiny fluctuations in space-time could have collapsed directly into black holes. If they exist, they could be as small as an atom or as heavy as a mountain. This is where science meets mystery. Some physicists believe that primordial black holes are the answer to the greatest riddle in science, dark matter. If the universe is filled with trillions of these invisible ancient relics, they would provide the hidden gravity that holds galaxies together. They might be passing through our solar system right now, invisible, untouchable, and older than time itself. They are the fossils of the Big Bang, carrying the secrets of how everything began. Level 5. The quantum black holes. We now leave the world of the large and enter the realm of the impossibly small. According to the laws of quantum mechanics, black holes could exist on the Planck scale, the smallest unit of distance in the universe. These are black holes smaller than a proton. They exist at the edge of human knowledge, where Einstein's gravity and quantum physics clash in a battle we still don't fully understand. Unlike the giants, these tiny black holes do not last. Through a process called Hawking radiation, they evaporate. A quantum black hole would flash into existence and vanish in the blink of an eye, releasing a tiny burst of energy. While we haven't seen them yet, they represent the theory of everything. In their tiny, fleeting horizons, they hold the key to unifying all the forces of nature. They remind us that even in the smallest speck of dust, the power of a black hole can reside. But wait, the universe has a few more surprises. Beyond these levels, we find binary black holes, two monsters locked in a fatal dance, circling each other until they collide with such force that they ripple the very fabric of space-time. These ripples, called gravitational waves, are the drumbeats of the cosmos. And then there is the most speculative idea of all, white holes, the mathematical opposite of a black hole. A place where nothing can enter and from which matter and light are only expelled. While they remain theoretical, they represent the ultimate what-if in our journey through the darkness. From city-sized corpses to galactic anchors, from ancient fossils to quantum sparks, black holes define the limits of our world. They are the places where time stops and imagination takes flight. They are not just cosmic vacuum cleaners, they are the engines, the anchors, and the ghosts of the universe. They remind us that no matter how much we learn, the cosmos will always have secrets that remain hidden in the dark. We've traveled from the smallest seeds to the largest giants today, but I want to know what you think. Which level of black hole do you find the most fascinating? Is it the ancient primordial ones or the massive titans at the center of galaxies? Let me know your thoughts in the comments below. I read every single one of them. If you enjoyed this cinematic journey, don't forget to give the video a thumbs up. Thank you for watching, and I'll see you in the next one as we continue to explore the final frontier.